by just making sure that our,
All right. Um, I see that there's you and David in the meeting. Can you guys hear me okay?
we can. And why don't we just talk at a relatively high level for a few moments on the theory
Absolutely.
that we might be joined by, well, I see we're supposed to be joined by a bunch of other people. So maybe speaking for a few minutes about your career and your background and how you got interested in the world of causal AI in particular. Oh, how nice, Mark.
Hey, hey, how's it going?
Our guest our speaker 2 weeks into the future. I just
Yes,
posted.
I just saw that August 7th, I think. Yeah.
Great. We'll make sure that I got all that right. But how about that? Could you start with your background, Robert, and how you got interested in this particular part of AI? Oh, Robert, are you frozen? Oh my. I hope Robert will soon return. Hey, Mark, why don't you give us a little introduction to
Hey, can you hear me now?
yes, now
Yes.
we hear you, but we don't see you.
There was a power outage where I'm at, and so I'm actually calling in from my phone. So,
Yeah, we can see you.
okay. But my slides.
If you want to email me your slides and let me show them on my side, that might be a possibility. Do I
Um,
already have your slides somewhere?
that would be really great. Um, However, the slides are online. Uh, Give me a second. I'm going to try and let me give you the URL for it.
That'd be marvelous.
It's URL tms.com.
Oh, wait, you're actually going to speak it instead of sticking it into chat or something?
I will try and stick it in the chat. It's just that
That's okay.
working
Whatever you want to do, just let me know what you're going to do.
working with the phone. This is wild. I complete outage. Let's see. CAI talk. Try that and see if that works.
Copy link. And it seems to be working fabulously.
Okay. And in the meantime, it looks like the power and everything has been restored. I'm going to try and log in on my computer. I still don't have any internet. So I'm going to just
This like it should work very well.
Good. Good. If you run the slides, I will talk.
I got the slides and you got the smarts, and between the two of us, it'll be an awesome
We'll make it
presentation.
happen.
Exactly. But did you
Well,
want to talk for a moment about
yeah.
your career and how it led to this?
Yes, I will. Hi, everybody. How are you guys doing? Hey, is it? Oh man, It's Mark. Yeah,
Yes.
well, I'm getting to the point in which I need glasses, but I'm fighting it. I'm sure nobody else can relate to that. So I'm having a little trouble seeing people's names, but I'll tell you a little bit about me, and I also want to find out about you guys. I want to just have this be interactive. So my name's Robert Joseph. I am the co-founder of a company called Team Mindshift, and we do transformational talent and workforce development in technology. And what that means is that we take people.
Frozen there. Is that me?
So when Robert has a problem, Mark, you're gonna. Oh, we just lost you for a few moments, Robert.
Uh,
3 sentences.
Sorry. So we work with large companies as well as workforce development organizations. My background is both my business partner and I are MIT alumni. He in mechanical engineering, me in electrical engineering. Got my bachelor's and master's degree there, and then went on to get a master's and a PhD in computer science at Carnegie Mellon, with a minor in artificial intelligence when it was almost cool. Um, I have been a university professor also for 16 years. I teach at Georgia State, web programming class, and other universities. I teach Emory, continuing education, and the like. As well as before Team Mindshift, I was a senior data scientist and a director at Stanley Black & Decker, doing IoT manufacturing type of work. Having said all that, recently started looking at causal AI, and am interested in it, but by no means am I an expert. So my talk is to get people interested in it, get people aware of the resources that are available, and really just to have fun. And so I'd like to turn this over to you guys and have you guys tell me, what is it that you're looking to get out of this conversation? Why are you here?
So I can certainly start.
Personally, Kent,
Sure.
Yeah.
were you about to speak?
Yes.
Yeah, Kent Pittman, I'm a longtime Lisp programmer, and I've been in and out of the AI community in various ways, but I don't really do AI. Um, I mean, I studied a lot of it back in the days when it was symbolic AI, and
Yes.
I often make the analogy that was like studying symbolic calculus or something, and the AI has become sort of like numerical analysis now, by comparison. And so, like, some of us are looking at this and thinking, maybe, well, we're looking for a way to marry back the old symbolic AI stuff because there's a lot of interesting computation that could be done more straightforwardly if you actually had a real model of something, or what I think of as a real model, which is means a symbolic model. I understand why people think that numerical models are legitimate models, and certainly for a lot of applications, they're the only available models. So I don't really mean to disparage that, but it's a completely different thing. And when you're asking something like what's 5 plus 5, going out and analyzing the linguistic structure of it and trying to find a probabilistic match or something doesn't seem like the most efficient way to get there. So when I saw this talk, I went out and I ran a couple of mini tutorials on causal AI, enough to just, mostly they were just talks people had given, to see what was involved in it and stuff. And I couldn't quite make sense of exactly what part it was offering automatically, what part was just kind of a philosophy and that sort of thing. So I'm hoping maybe you can clarify some of that, I guess, is where I'm starting from here.
Okay, we'll start. And I love that you are a Lisp programmer. That says a lot, because that's what I did my dissertation, and I programmed in Lisp. So that was a long time ago. Who's next? Who would like to talk a little bit?
Kent has no recollection of this. But when I was just getting out of college, I had an interview at Symbolics. And I somehow got myself into the MIT AI lab, and I found Kent, who at that point was still already a well-known expert in Lisp. Had you already published the Lisp 1.5 manual at that point? What year?
Not Lisp 1.5. That's McCarthy did that.
No, the MacLisp manual.
I did I
MacLisp.
did a second version of the MacLisp manual. Yeah, and that was probably all I
Anyway, for some
recorded.
reason, he was already famous in my world. He showed me DDT and that you could call the elevator by doing some weird thing on these DDT machines. And so like so this one then when I did the interview, I said,
I'm going to link something on the conversational chat here because we just recently had some discussion in Mastodon where I went at length and talked about that particular community, and anybody watching this on the replay might find it fun. But anyway, go ahead with that so you don't have to go into detail.
So anyway, so my history as a Lisp programmer is punctuated by a very memorable for me and completely forgettable for Kent afternoon at the AI lab. So I'm very curious about the general I mean I like to think about like various toolkits. LLMs are a bunch of cool toolkits that I want to be able to use in various ways. And certainly reasoning about causal things seems a very exciting thing to want to be able to do. So I'm looking for an introduction.
Right.
Awesome.
Awesome.
I'll go next.
All right, Mark.
Robert, to answer your question, ignore my parrot, but mute myself in a minute so you won't hear him. Yeah, so I also am a enthusiastic Lisp programmer. My company bought me a Xerox Lisp machine in 1982, and I've had a number of commercial products in the 80s that were either prototyped or actually shipped in Lisp. For the last, I ran a deep learning lab and team at Capital One 7, 8 years ago, and that kind of really got me feet first into deep learning and neural networks again. And really for the last maybe 2 or 3 years, it's all been large language models. And I'm also fascinated by the interaction with symbolic AI. But the interesting problem that Kent just pointed out of asking an LLM to add like 5+2 or something, to me that's teaching them to use tools and call out to a Python interpreter to get around that. So I guess I'm interested in what engineering tricks can be used to get around their obvious limitations. And now I'm going to mute myself so you don't hear my parrot.
Thanks, Mark. Kent, some of the community. I didn't quite get all of that. But anybody else want to take themselves off of mute and talk?
Yeah, quick one. My name is Keith Corbett. I know Kent, and I've known Mark indirectly, and also from the Lisp community back to 1984. But in the early 2000s, no, actually a little later than that, I also got involved in semantic web, and I think that semantic modeling and inferencing really go hand in hand. Reasoning over a model makes a lot more sense than sort of a probabilistic prediction of what words should come out of what other kinds of words. So I'm very skeptical about LLMs beyond the sort of tricks that they clearly are capable of doing. But you can't ask an LLM to explain why it emitted a certain blob of text. And that's really, when I think of causal AI or deterministic AI, those kinds of terms, I think what we're really asking for is being able to backtrack and explain how a prediction or a correlation or a suggestion is made from a model, and LLMs are notoriously silent on that. So I'm hoping that plays into this as well. So I think causality and correlation are different, and it's they're interesting differences.
Yes, they're very different, and the whole causal AI branch of research is fascinating to me too. So Yeah, we'll definitely talk about that. Thank you. David, Ty, either of you?
Yeah, sure, I can go.
All right.
My name is Tyree Crisp. I am a software engineer, back-end software engineer. Currently, I am a involuntary freelance engineer. So, in my free time, I look for more work to do and also find different groups, and that's kind of how I came across you guys. Was just in my involuntary freelance free time. I was like, oh, why not? So I actually don't know much about causal AI. I've seen generative AI before, but I haven't seen causal AI. So it's interesting to see like what you guys can offer or what I can learn from it. Thanks.
Ty, I don't have any of your contact information, so feel encouraged to put something into the private chat. And that's true for anyone else who knows that I don't have a way to reach them. I'm Eric.
Yeah, I'll send it to
Nice.
you.
Thank you, Tyree. And yeah, and for everybody, let's connect on LinkedIn. My LinkedIn link will be at the end, but it's Dr. Robert Joseph, all one word. And I love to connect with people. And this is my first meeting here. I met Eric about a week ago, a week and a half ago, and through a mutual friend. And so now I'm talking with you guys. So lots of fun. David, would you like to say something? Thank you, Eric.
Oh, I got it here. So hi everyone, I'm David Karchov, and I spend some time also teaching at university, numerical, like applied mathematics, and then I joined IBM, and then I moved from something useful to management positions. So I'm just getting back out of there. So I didn't hear fortran, that's what I used, and I used assembly language in the past just to show that it's the same category of early starters. And so then I used C, C++ in my past life, and then now I'm doing Python interpreter, some applications, web applications. So that's where I am, and I'm here out of curiosity.
Nice. Well, awesome. Well, we can bring up the slides now, Eric, if you don't mind. And I also see that I think we have a more stable connection now that the power has come back on. So I'm also going to try and connect via my computer because that'd be a much more easier environment to work in. So just bear with me while I do that. All right, awesome. Next slide. And also want to just make sure that you guys can see me and hear me. You guys, can you see me okay? And can you hear me okay?
I hear you and I see slides.
All right. Okay. So today's goal is really to have fun and continue developing a causal AI mindset. And yes, the slides will be available. That's a question that everybody always asks. If you go to the next slide. And there's the URL for the slides. So you can follow along and all of you note takers can rest easy, or you can still take notes, but at least you'll have the slides to work with.
can go to the next slide. And if you want, we can switch over and I can run the slides now that I have the ability to, Eric, so I don't have to keep bothering you.
That sounds fine.
Okay, cool. Share slides. We're going to share here. And
the agenda is what is causal AI, advantages of causal AI, and real world examples. And there we are. Good.
Yep. And then we'll just talk about other things that you might want to look into in terms of using causal AI. And it really is about having a discussion. So at any point in time, if you have any questions or want to talk about anything, just go ahead, either raise your hand or even just take yourself off mute and start talking. We were a nice small group, so let's have some fun. So what is causal AI? You know, you always have to start these things off by saying that correlation does not imply causation. And I think that's one of the big things that you said, Mark. And it's really interesting because there's some things that, for instance, ice cream correlates with shark attacks. You know, the more ice cream that's eaten, the more shark attacks there are. But that doesn't mean that if we stop serving ice cream, that all of a sudden sharks will stop attacking. Another one that people talk about is that people who eat breakfast face a lower risk of coronary heart disease. So that people that eat breakfast has been correlated with people that have a lower risk of heart disease. Again, correlation does not create causation. And what causal AI is about is really tying the knot where you can say that this causation has a high probability of this correlation has a high probability of this correlation. This correlation has a high probability of this causation. And then being able to not just say that, but be able to connect some percentages of how much of different aspects of things cause a particular event to happen or a particular thing to come about. So, you know, what if we could define causation? What are some of the things that we could do with that? So not just causation, but really saying that, hey, when this happens, or these set of things happen, then there's a high probability of this other thing happening. Or when I see these particular things, and there's a high probability of this other activity or other aspect happen. What would that be able to do? And there are a number of tools that have been used before, but it's been very expensive. So some of the methods are around A/B testing, but that has some problems. So when you start talking about A/B testing, let's say you're A/B testing a drug that could save somebody's life. And so you give one group of people the drug and another group of people the placebo. Well, that has a lot of moral implications to it and a lot of really expense to it, a lot of really denying people a thing that could save their life. It has a number of aspects to it. But through A/B testing, that has been one way of looking at causation and correlation, or correlation leading to causation. So causal AI is a field where you start to be able to look at data that's already there and starting to determine the causation and the correlation and the causation components of it, or more so the causation components of it. So here's an example. Let me just pause here and see what questions there are. If there are no questions, I'll keep going, but I always like to pause and see what questions people have or comments.
Only that you have me on the edge of my chair, and I really want to know, like, where the AI parts fit in versus things people do using statistical methods and stuff. So You just had me very curious.
Good, good. Well, just to make a more concrete example, a well-known correlation is in Central European towns. There's a number of storks nesting, and there's an increase in human birth rate. And this is where at least one of the myths about storks bringing babies comes from. And what really is going on is that because of the way the town is structured, where the buildings are so close together, there's a high dense population there. And the way that the houses are structured, it creates a great breeding place for storks. And with a large population, it also creates a great breeding place for birds. And so it's one of those things that, again, shows that causation does not necessarily mean a correlation. I mean, correlation does not necessarily mean causation. And I have references on the bottoms of the slides so that you can go and read all about them and that type of thing. But I want to play this from the Microsoft research, because a lot of companies are putting in work to understand causal AI. And this is a really good video. So let me cue that up. Let's see. Are you guys able to see the whole video?
I'm Chang from Microsoft Research.
Okay, great. Thanks, Mark.
I'm a principal researcher in machine learning. Today, I'm going to talk about our project Corsica. So this is a project about decision optimization with causal machine learning. So the holy grail of decision optimization is the ability to answer what-if question. Imagine if you are a medical doctor, if you know what happens if you give certain treatment, how to choose the treatment will be very easy. And if you are a sales manager, and if you know what happens to the revenue if you give certain promotions, the decision will also be very easy. So in our project, we would like to automate this process and optimize decisions with machine learning, and in particular, causal machine learning. To answer such questions, we need to understand two things. One is understand the relationship between different variables. For example, if we give like a membership out, will this increase like the number of service on our Azure cloud? And will this drive the revenue afterwards, right? So we want to understand the causal relationship. And another thing we need to understand to finally answer question is the consequence of the action. How much is the revenue growth if you give a discount or if you give a membership? And this we commonly call causal inference. So both parts are needed. So our team is actually the first team in the world that we bridge causal discovery, causal inference, and deep learning into a single framework, so that we allow users to provide us historic data, and we can answer all these questions, tell them the relationship between variables, tell them the consequence of different actions, and be able to recommend optimize the decisions. So there is a lot of research ongoing, and this is a framework bringing us close to real-world impact because it's flexible, scalable, and be able to deal with all type of real-world data. And so in our mind, in research, this is at the dawn of a golden era. So apart from advanced research, our team is really rooted in real-world impact. So the example we gave about sales, we're actually working with our Microsoft Global Channel Sales team to help them to optimize the engagement decisions to drive the revenue growth. Apart from the sales application, we're in active conversation and collaboration exploration with AI for industry, gaming AI, and many other departments in Microsoft. And so, of course, with our team's aim is actually to empower everyone and every organization in the world to be able to do decision optimization with causal machine learning. So we're also exploring collaboration with platform level service, for example, cognitive service, to make an even bigger impact. So if you find that this type of research can help you, or if you want to collaborate with us, please contact us.
So let me pause here and see what do you guys think of the video and what questions do you have right now? And we'll continue on, but
Is it open source?
yes, actually it is.
Yeah, okay.
And there are actually a number of people that have come out with open source frameworks for being able to do it. It's really kind of cool. Let's see.
I guess let me to summarize the point that she was really trying to make, that there are these different pieces of technology, and we're and they're trying to find ways to get them to play nicely together. Can you summarize the bottom line key point, Robert,
Sure.
what she was making in that video? Thanks.
Sure. I think the key point that she was making is two. One, there are techniques to really create a good model of a causal relationship between different entities that allow you to predict the future basically by pulling a few levers, saying, if this state goes up 10%, then that'll mean 2% increase in whatever the results are that you're looking for. And so there's that. And then the second thing that she was making is that, hey, this is also one of those kinds of research that has has a community of people that are working at it through multiple different companies, multiple different ways, multiple different disciplines. And so it has some teeth to it. So I think those are the 2 points. Did that answer your question, Eric?
I'm a little bit confused about, I can certainly, trivially think about ways I would represent beliefs about causality using frame-based knowledge representation, all kinds of symbolic ways of doing it. Are those relevant, or they're doing something that's much more, LLM-ish, or like I'm wondering
How does it
we're
get
kind of
done?
lacking context.
Yes. So as we get more into it, I'll talk about how it gets done. But let me give you a framework, at least one of the frameworks that is being used. One of the frameworks that is being used is that you create a causal model based on certain data points. And that causal model is created based on the data that you have. And then you run that data through some analysis similar to a machine learning model, but it's a causal AI model. And then through the running of that running of that data, you start to see the impact that each of the different elements that you've modeled have on the final results by looking at the real world data. And then after you get that baseline, then you can start to experiment with the data that you have by changing it slightly to see the effects that each of those components have on the causal model. Does that help to clear
That's
things up?
starting to be clear. As far as I'm concerned, you can go on.
Okay, cool beans. So let me just talk about the advantages of causal model that you might not have thought of, and then we'll get into at least a little bit more in depth of how the model works. The first thing, and this is one of the things that I think it was you, David, or somebody said, or it might have been it might have been you, Kent, where you're talking about, deep learning and LLMs. They're all kind of black boxes. You really don't know what's happening in them. But when you start to use causal models, you actually have a model of what's going on, and it makes sense to human beings because that's sort of the way that we think, or at least It's the way that we think we think. So one advantage is it removes the black box component. The second advantage, which is really cool, is that when you start modeling things in a causal way and start understanding them, then you can also understand where biases might be introduced, and then try and pull those biases out of the model so that your model will help you to make adjustments in behavior if you're using your model to make decisions. And here's one, and again, these are examples of different articles or papers that have been written on the topic. But in this case, there was a comment about predicting income. And part of what was part of the model was gender. And so if you have a model that has gender there and it is behaving in a biased way, then you could say, okay, let me now run this model without gender and start to see results and start to make decisions that are not as biased. And of course, you need to test these out. It's not just you do it blindly, but it gives you a better starting point. The third example, and this is one that is really interesting because, you know, well, I don't know about LLMs, but a lot of the AI-based deep learning and machine learning is based on the data that is being presented to the system. And although when you have a causal model, the model that is created is not tied to just the data it saw, but it's tied to the data that it saw to come up with a model. But if new data that it's never seen before is introduced, you still have a model that can do a prediction. And so in machine learning, if you have, you know, a bunch of data that's really around sort of a certain amount of data, and you introduce some data that's outside of what it's seen, then the deep learning and machine learning kind of break down. But in causal models, you can do that and it doesn't break down nearly as much. So that's another advantage of it. And then the fourth advantage is that it also provides an understanding. And one and four are very similar, but it really does allow you to say, okay, these are the factors at least that we're looking at in the model and the effects that they have on that final results. So let me pause here and see what questions or comments people have.
Can I just say that I think that looking for bias and correcting for bias is a great way and a great lens into critiques of these kinds of systems. And what I was thinking about when you described taking gender out of a causal model is, you know, this comes up in hiring decisions and salary decisions and credit decisions and so forth. And the more we turn these over to black box AIs, the scarier the future gets, I think. Whereas if you have a conscious expert system, something where you can look at the rules and the semantic model, you can say, oh my gosh, we built something that has bias in it. Let's take that out by hitting the delete button. And I don't get the sense that that's what this is. Maybe it helps. So I'm eager to hear more about that.
It helps, and I think that that's an advantage of it. It's not the key selling point of it. But it does help and it does allow that. And of course, with all of this, it's a little bit more complex than just hitting the delete button.
Yeah, I don't think it should be. That's my contribution. It should be as easy as looking at explanations of inferences and saying that went down a wrong path and we're going to make that against the law.
I laugh because I totally understand your sentiment. And then when you get people in the mix and all the other stuff that go along with stuff that's not strictly technical, then things get a little bit messy and gray.
So
Because then you have the whole conversation of, well, is that really a bias or isn't it a bias? And some people argue one way and other people argue another way.
I have a question.
Sure.
I got interrupted in the middle of the little thing you were playing before, so I hope that it wasn't answered there. But
Even if it was, it's okay to ask it again.
Everybody's been talking about AI these days, and it almost has become synonymous with LLMs. Although I think that, so part of my question is the data that you're starting with, the landscape that you're working on, does not seem to be the sort of unstructured data that's going into an LLM. Are you starting from systems that are more conventionally ML kind of things where there's sort of a smaller amount of data or a smaller dimensionality of the amount of data, first of all?
Yes.
And then to sort of understand, you said you were going to go through a little bit of methodology, and maybe you'll get to this, but I sort of don't understand whether we're starting from a sort of ontologies or other kinds of structure information that the system knows, or if the system is trying to infer it from the data, because it still seems like once you pour in kind of a lot of data, that although there are causal things that are in there, that there's many kinds of potential things. There's the ice cream and the shark thing or something is in there. And I assume that the number of actual causalities is sort of dwarfed by the number of just random correlations and so on. So I don't understand whether the methodology is you start with something that's approximately correct and you're tweaking it, or whether it's an entire research project just to find a single arrow, or whether it's
I got you.
that a researcher might do in an afternoon where he says something meaningful about like how we're going to treat this patient or something like that. Like those are very different processes, and I can't sort out where we are in that sort of overall process in terms of the technology.
Yep, I understand your question, and thank you for that, Kent. And so this is structured data, and it's a few parameters. So it's the parameters that you're looking for a causal relationship to. And there is research going on in this area that's constantly evolving. But this is very different than LLMs. It is looking at, and it's not only structured data, but it's structured data that has the value, the results in it. So it's not a clustering. It's actually more in line with a prediction, machine learning predictor. Does that help clear it up some, Kent? And so
I mean, I expect you to say things like that, but at the same time, it's not as specific an answer as I was looking for.
Well, there are, and when we get to the end, you could actually go and play with some code examples and stuff like that. And there's a methodology. There are a few methodologies that are there. Some methodologies allow you to put in data and it derives that set of correlations that are in the model, some, and then you could take those correlations and run them through again to see if they really are causations. And then others say, hey, create what you think are the causal relationships, not necessarily the values, but the causal relationships that exist. And then it'll run the model through that and then try and predict the amount of each weight of the different attributes and how they affect the results.
By the way, quick idea for a future talk, Robert.
Yep.
So there's this amazing podcast that I love called Strict Scrutiny, where the economists are talking about, I mean, they do these natural experiments and they use particular statistical methods like difference and differences, and so they'll kind of figure out, is it better to let people out of jail without some kind of halfway house, or to put them through some kind of halfway house in between? And these folks use really good kinds of clever ways to get to a controlled clinical trial like level of proof, even though you're not able to assign people, totally at random to. So anyway, it'd be fun to bring someone in who does this kind of research along with one of those economists, to talk about, how these two kinds of reasoning about causality might work together. So I hope that you find that intriguing. Oh, I think, did we just lose Robert? Hold on. Robert's Fathom is still here. Well, while we're waiting for Robert to return, Mark, we can talk a little about our an upcoming meeting. Let me spot you, add the spotlight here. We'll do a little marketing while we're waiting for Robert to return.
Okay, am I unmuted? Yes. So my talk was going to be very simple, a warning. I was going to take 3 examples from my recent Lang chain and Llama Index book, and have the source code in an Emacs buffer, walk you through the code, and hopefully be a jumping up point for discussion. So,
Let me
okay,
just
Robert's
quickly,
back.
Mark,
Good.
we'll get back to Robert in 1 second now that you've returned.
Sorry,
But
sorry.
Mark, why don't you tell us a little bit of what those tools that you'll be using, talk about Llama Index, and just talk about those tools for 1 moment. I want people to
Sure.
fully drooling for your talk.
Yeah. Llama Index has connectors to like many different kinds of data, doing RAG, retrieval augmented generation systems. LangChain is sort of a abstraction over using large language models, available in Python and JavaScript, and it'll be fun.
I'm looking forward to it. Okay, great.
Good. Okay, now
but if Robert disappears, assume you will suddenly be asked to do a little bit more marketing. Let me see. I am stopping my video. Okay, good, Robert.
You're muted, Robert. Robert, you're muted.
Yep, thanks.
There we go.
Sorry about that, Eric. You were in the middle of a recommendation, and that's when it dropped. I think we're having storms here, and so.
Oh, right. I was just pointing out that I think it would be awesome to take one of these economists who gets featured on Probable Causation, this wonderful podcast where economists they study things like driving while black. You can't randomly assign the race of the cop and the race of the person being stopped by the cop. So how do you prove causal relationships? Well, they use things like nighttime. And so it'd be fun to have somebody who does that kind of research where they're trying to figure out causal relationships when you can't actually do random assignments, along with one of these researchers. I think it would be fun to have kind of a conversation. So that was, I would love it if you'd be interested in helping to pull something like that together. Anyway, you've got your slides, so.
Yes, I laugh because that sounds very interesting, and I have a company to run, so which is always a time factor. But to your point there was a study done by either Lyft or Uber to that specific point, because they have so much data on that information, and they combine that with data public arrest records and things of that nature. And so there is the ability and that's and the reason I bring that up is because that's the really nice thing about causal AI is that you don't have to do a study that is defined, but you can sometimes with enough real life data get to some of the hypotheses that you are looking into.
Cool.
Speaking of Lyft, let's talk about a real world example. Well, here's one example, and the problem is to rely on observable data. So you don't have to create a specific study for something, but you can take real world data. And this one is showing the effects based on social and economic indicators for training program effectiveness. And this data, I think, came from a European study. And it looked at the learning material, it looked at the time spent on the learning material, the engagement activities, the completion rate. It looked at a number of different things and identified what were the things that contributed to students struggling with specific math concepts. And so you can read more about the study at the link below, but it was able to build a causal model that then teachers could use and say, oh, okay, these are the kind of levers that I can pull, and this is where I might need to put more of my effort into in training students and helping students out. Another one is with Lyft. The interesting thing about Lyft is that the way, at least when this article is written, the way that Lyft is set up is that it has a number of different departments that are all trying to optimize their own department goals. And optimizing their department goals doesn't always necessarily optimize the company goals. And so what they did was they started to create causal models in each of their departments and then pull all those causal models together so that then they could have a more global model of the effects that one change in a department will have on the whole company versus that optimization that's local. And this article talks about that, and you can read more about that.
You know, excuse me, I was going to ask you real quick on the Uber example. I was wondering how much that's used in real education systems. At my last company, my best friend was in China, and Jingtao had a 10-year-old son, and he talked a bit about his son's educational system. And it's almost all driven by AI, and the teachers spend about 100% of their time just one-on-one with individual students, and everything else is trying to figure out what material, automating what material to show students. And I was wondering, since that sounds like maybe a causal model, if you had heard of anything dealing with that.
Yeah, we, as a training company, we've been thinking about those kinds of things too. The interesting thing is that when you start looking at the research of causal AI, it's being used in a number of different places, education being one of them, of course, marketing another. And, and the example that I gave wasn't Uber, just to be clear. The learning example was, I think it was a government entity that did it based on the government data that they were collecting. And then this is Lyft. When I was talking about Uber, I think it was either one of the causal articles that I read when I was doing research for this was either Uber or Lyft having all this data, and they asked the question about does race contribute to being pulled over? And since they had a lot of information about their drivers and they could get public records about information about the police, they thought, oh, this is something that we could put together and research. And so that's when Eric brought that up as a topic, then that reminded me of the article that I read surrounding that. Did that answer your question, Mark? Awesome. Cool. And so at this point, I would say, this is your turn, but you guys know how to think about causal models and create those causal models. But this next slide, I want to talk about, here's a path forward. There is a number of software libraries out there. One that is by Microsoft, and you saw that. The PY, it's a Pi library that allows you to first do your own causal model and then put data through, and it actually walks you through. So if you go to their website, it kind of walks you through the installation of it. If you go to the GitHub for it, let's see, I think I have the GitHub. Yeah, you go to the GitHub repository, then it has a number of examples where you can see exactly how it works for additional research. But then you also have Uber created its own library called Causal ML. And again, these are the links to it. And IBM has one. I think, who was it that worked at IBM? I think it was you, Mark, right? Or David, was it you? Somebody was.
David is definitely a former IBMer.
Okay. So IBM has their own model, and these are the GitHub repositories. The other thing that's really cool is that there's this Discord channel in which there are a bunch of people that basically work with PyY, and they have office hours. So if you have a causal AI question, you can ask them during office hours. They have talks that are given. So if you really want to start getting more into causal AI, here's a good start. A good start of the resources that are there. And then over on the right side, I just put a few of the articles that I went through that I read that really helped to crystallize some of the concepts that I talked about in this video. So with that, I open it up for questions. And again, you guys have access to these slides and all of the links and everything.
So it's really Eric's job to invite you back, but I wanted to say that, like, I still wish that I had, like, I don't know, like a day in the life of, or something like that, where you just brought up your screen and said, here, I'm working with this thing, and I could see, like, this is what I type as the input. I already have the stuff downloaded. You can figure out how to do that yourself. Like, here's what I put in the way of rules. This is what the interactions look like. Just somehow, I mean,
Gotcha.
it's not just you, and maybe you're just saving that because I notice you do some stuff with LinkedIn Learning, and so, like, maybe you're going to, like, do a little course or something like that. And if you put it in the course, that's fine too. But I know that Eric would probably not fight you off if you said you wanted to come back here and just sort of try some rough drafts of it or something and get some feedback.
I hear you, Kent. So if you do, I am a LinkedIn Learn instructor, and if you do have a library card, you have free access to LinkedIn Learn. And if you just go and search on Causal AI, the last half of the course is going through some examples with code, and there's a GitHub for the code and that type of thing. And I will say that I hear you, Kent. I think the other thing is, and the really cool thing is that um, this GitHub right here, it really does, let's see, one of these, really does have a step-by-step example. It's been a while since I've been in here, but there's a step-by-step example of a hotel and hotel stays and using coupons, I think, at hotels where you can actually, it's a collab or a notebook, that a Python notebook that allows you to kind of go through the code. So yeah, and that's what I did. So I just kind of went through that, but I do hear you. So I'm not saying
That does sound like
that I
a
won't
fun
come back.
follow-up if you're willing to do it.
I'm just saying that I'm saying that here's some alternatives instead of just waiting for me to come back.
Yeah, and also from you or anybody else, Mark, there's some underlying basics that, like, like I've had lots of courses in logic, and long ago I studied probabilities, but like I haven't used it for 30 or 40 years or something like that in any like day-to-day way. And so like as I was reading through this, like people were talking about, and I don't even remember the exact term, but there were some Bayesian equivalents of the rules of logic. And so as I'm like processing those in my head, I'm thinking, well, they're going to have exceptions, and like, is that like, how many exceptions can they have? Is that about like standard deviations and stuff like that? Are they like approximate rules, or what do you do with the counterexamples, or do they cause you to have to factor it out into different sets of rules? And like exactly how you manage probabilistic logic is not at all obvious to me. And if there's somebody that like does that on a daily basis, and like in a real universal quantification or something like that, you would say, oh, wow, I found a counterexample, so that can't be true. But in a probabilistic situation, is that really true? Like if you're doing a medical thing and you see like one counterexample, do you go like, well, that drug will never work? I just don't believe that that's really going to be true. So understanding, even without any of the tools, what is the sort of basic system of logic that would guide me to understanding how to navigate this space is sort of a separate question that I would have, that I would love to see somebody come in and just give us kind of an overview towards, just to get us something to dive in and read Wikipedia pages, or to know what tutorials to search out, or how to blunder our way through.
One of the things
What
I
kind
would
of,
say,
oh, sorry, go ahead, Robert.
yeah, just to piggyback off that, one of the things I would say is if this is a really interesting topic for you guys, and it sounds like it is, connecting with the people on the Discord, and I'll put the Discord link there. I would imagine that there are talks that are already what you're looking for, and there are some talks that combine LLMs with causal AI, and if there aren't any that hit the mark, I'm sure that you could just put a call out to somebody to come and say, hey, you want to do a talk on the latest thing you're working on, causal AI, and they'll come and talk with you guys too. So that's another source for it. My job is to get you interested in it and give you a little bit of guidance on where to go, and then I pass off the baton.
Well, I've certainly appreciated that.
Yeah, this has been fun, and it's been great meeting you guys.
We hope you'll come back, join the meetup.com meetup. I just stuck into the chat this woman, Jenny Williams, who is I think she's an Australian researcher, and it's one of my favorite examples where she studied what the effects of electronic monitoring bracelets relative to actually sending people, I guess, nonviolent offenders to jail. And like obviously sending people home and is like ridiculously cheaper, right? And but way more effective in terms of reducing recidivism, as it turns out. I mean, if you think about like normalizing in people's heads criminal behavior, sending them to be in a place with other people convicted of crimes, right? Probably shouldn't have really made any sense. But by the time she completed this research, the program she was studying had been shut down by the politicians because they're rewarded for being tough on crime, right? So yeah, we've got a world where policy making that actually is based on good data and good causal reasoning is by no means 100% of the time.
Yeah, unfortunately.
Other questions?
Kent's,
Go ahead.
Kent's comment on being walked through something uh, and Robert's links to the notebooks we can follow through on PyY made me think that I should not do my short talk in an Emacs buffer. I should make a couple Google Colab notebooks.
If you don't mind.
more reproducible for anybody.
Oh, damn. Yeah, no.
Yeah.
Collabs would be Google Collab notebooks would make it much easier for people to jump off of what you're doing. Good.
Yeah.
Oh, Robert, you've just given us additional value.
There you go. Just to bring home some of the tutorial questions that were asked. I put this link in chat. Here's a number of different examples where you can go and it actually walks you through the different codes, telling you about it, giving you how it works with this particular library. And it has a number of different examples that you can try to your heart's content. And they're all pretty cool examples. I didn't do them all, but I did a few of them, and they're kind of neat. So I think that answered your question, Mark, about the tutorial. And yeah, it was interesting, the DOJ stuff that you were talking about.
So the best link that people should really have for your slides is where? Can you mind sticking it back in one more time?
Sure.
I put it in right at the very beginning. As soon as Robert read it out, it's in the chat.
Yes, I'm scrolling back looking for it, and I was having trouble.
Let me see if I can find it. And I'm sorry about the world throwing.
There it is. There it is. That's good. I'll copy it again. Copy and paste it in here at the bottom. So, oops.
Awesome. Thank you.
Any last questions for Robert or requests for Mark in his upcoming talk? You are required to attend Mark's talk, Robert.
I'm sure it's going to be really great.
Thank you for that. I consider myself pretty good at several things in life, but public speaking is not one of them. But I'll put some effort into preparing.
Well, you seem to be able to speak in public pretty well today.
Well.
All right, guys. Well, once again,
thanks, Robert.
Thank you for allowing me to come and talk with you guys, and love to connect with you on LinkedIn, and let me know how things are going from time to time. And who knows, I might be able to stop by. There's a lot going on in my life right now, so
totally understand. It was fun to have you this time, and we hope to see you again.
All right, guys. Take care.
Thanks, Eric.
Yep.
Thank
My
you
pleasure.
all.
All right.